Welcome back. My name is Paulaj Biswas, Assistant Professor, JS College of Engineering, Department of Mechanical Engineering. And today discuss the hidden line surface solid renewable algorithms. And this is my lecture number 19 under the paper of computer aided design. The visible surface detections. This is the first is come here that like your the visible surface detections we have to consider. That is the problem is given. The given screens and the projections. What can you see? You see we can hear, and just like your the first box to your the consider to your the second box, but first is not will be the solid will be considered. This will be on open concentrations is here, but you have to gain seen during toward the this type of projections also you can concentrate according to the visible surface detections on is considered is here. The visible surface detections too. That like use the terminology. The view terminology is considered, that means your the visible surface detections versus hidden surface removal. The visible surface detection, that means you have to first detect the which one will be the visible and the which one will be placed here. The what will be the length of your arrow will be here, and what is your the is the given. That like your the which surface is the here. This is considered according to your the visibility. Suppose we can easily consider when you have to work with the um, uh, Microsoft Words, then you have to first creating a tables, and again you have to hidden your this table that like the and options will be given that like your the hidden this will be removals, and also the first you have to draw during your the visual surface detections, and again this will be the required for your the hidden case, and the hidden lines removal versus the hidden surface removals. And basically you have to consider according to the hidden line removals. That means your hidden lines is a few cases you have during to your the words work that like the few lines will be considered according to hidden, but not will be remove these lines. But another case is the hidden surface also will be available, but you cannot be remove this surface. This will be here the terminology, and the many algorithms is here that like your the complexity screens and the type of objects and hardware will be consideration according to this your the here the many algorithms, and the visible surface detection is here. That like the two main type of algorithms is used, the object space and also the determine which parts of the object are visible, and you have to concentrate that means your the object space, and also you have to record for your the determine the which object are visible and which also not will be the invisibles, and not will be considered according to this. And another things, the image space also will be considered. That suppose your the object space and also the image space, you can see your object first will be required that like your the object space is given, and your image space determine the per pixel which point of an object is visible. That like your consideration is the image space. This will be here, and this is the given that like your the object, and also your the pixel concentration, your the image space is here, and visible surface detection is 4 is considered is here. That like the visible surface detection is equals to short for depth. That like your the short for depth, hot and in hot order is varies here. That like your the performance is here, the use the coherence. Now that like your the object is considered according to the coherenceness, and that this object is here the positions in world space. That means your the that your the performance and also your the coherence will be considered according to your the visible about the surface detection. Then you will be required for your the which place this will be the positions will be considered, and also the position in image space. That like your the suppose the one image to your the another image some space will be required. That like your the what is your the positions will be very bad. That like your the visible surface detections will be considered according to this, and another cases will be considered according to time. This like your the positions, and like your the image will be come during to this the depending on this the time variables, and this which time is required. That means the 1 second, 2 second, and what is the staying times you have to visible of your the objects, then these things will be depends on your the time periods. The visual surface detections 5 for algorithm that like the back face eliminations, depth buffers, the depth sortings, and the recastings. The recastings, but there are many others also will be considered according to the visual surface detections here. And another thing is the back face elimination is on. We find here that means that we cannot see the back face of solid object. The hence this can be ignored. Ignored is here. Um, you can see that like this will be the 3D object is given here, but on is the x, y, and z axis also will be here. But you have to here that like your the back face, that back face eliminating. Suppose you're the you have to concentrate over the back end of your the red arrow is given. It is the on blue color is concentrated as your the back face, and also you have to require for your the back face will be eliminated, and again you can be ignore this, and also you can be ignored this, and also you have to v dot n is greater than 0, that is called your the back face is considered is here. The back face eliminations 2 is here. You can see we cannot see the back face of solid objects. We can easily see that means your the cannot be seen of your the solid object, but you have to require for your the back face. But this back face is replaced to your the forward face, and again the in front face you have to see your this object, and again the you have to remove your this is easily, and again you have to consider that means the hence this can be ignored. The b dot n is less than 0, that means your font face is comes here, this font face, and again you have to eliminate these objects, that like your the back face eliminations is comes here, and this will be figure is here. The back face eliminations 3 will here. The object space method, that is your the objects is given, uh, your object is given here. You can see the object space method, the backface eliminating 3 is considered according to the object space methods. That like the first object you have to see, and the works fine or for convex, the polyhedra is here, that like to the plus minus 50% removed. The you can see that is the first one will be a solid shape, and the second one also will be considered according to the partially visible font face also will be here, and this will be considered according to your the third ones. And another things is here that like your the concaves or the overlapping polyhedra is considered according to use, and also the required the additional process, that means your the additional process is implemented. The interior of objects cannot be viewed, that means you are the partially visible, and you have to given to your the right bottom corner, that means the red arrow is given to your the downwards direction, unless you can see the this is the one face will be vanished, that means your one face is vanished, that like your the 50% removed, not will be the 100% removed, 100% removed, because the 100% remove you have to understand the which will be removed, you can see, and also you have to given to your the red arrow. The depth buffer algorithm on the image space method, that is the aka z buffer algorithm. You can see this is the one euler region, and another things will be considered according to this the xv, yv, and zv, but you have to use during toward the blue zone, and space method will be considered according to your the blue zone is here. And this will be normalized, the view of this the volume is considered, and also this is the view plane, and this view plane is comes like your the blue region, and again you can see the different shape will be pixels is come, that like use these pixels, And another things you have to passing through this your lights, and that like your the red point is considered according to your the pixel, and also the font visible point is be considered according to your the font visible points, and that like your the normalizing view. And you can see that this also will be shifted is here. And during to this the algorithm draw the polygons, that means your the algorithm is comes here to the polygons. And remember the color must in font is here, that means your the you have to consider according to your the color, this will be considered in the in font of your color is considered is here. The color must in front of this. And again the this will be this is the AKA and the jet buffer algorithm is used like your the normalized views volumes, and also the this view plane is here. And depth buffer algorithm 2 is considered. This is the where jet buffer, that is the dot arrow, this is the the bracket is here nn for real. And the jet buffer, that means the 0 equals to near, the 1 equals to far is considered, that means you have to consider according to 0, that this is the considered according the near is here, and 1 equals to the far is considered. And another the f buffer, that is the array, and the n is here, that means the color. And the frame buffer is here. And the for all the 1 less than equals to I, that is the j less than equals to n2. And the z buffer is considered, that is the ij ij equals to on 0. And call that is the ij equals to backgrounds color is considered according to this for all polygons. Do the scan conversions is here, that like the for all converts which is, that is the ij. And you have to consider according to this uh, yeah, that is a calculated depth is considered, that means your the calculated depth is z. If the z less than z buffer, that is the ij, then the second brackets closure is here, that is the on a program is given. And during to this the z buffer, that is the ij equals to z. And the jet buffer ij equals to surface color is considered ij is here. You can see that this will be the sortings, that means your the sorting is comes during to this depth buffer algorithm is considered, that means the surface color will be here, that like your the ij is considered. And depth of algorithm 3, for the first calculation z use the coherence, that means you are considered according to your the display. And during to this polygons will be considered according to your the your uh, blue color is given. You can see this is your the polygon. And color will be changed, that means your the scan line is here, that is during to your the scan line you have to consider xy directions is here. And the display is find here. You can see that like your the y x plus y is considered according to scan lines is here, that like your the display is found. And also the different arrow, and also the plane is to 1x plus ax plus by plus cz plus d equals to 0 is considered according to your the calculations. And hence the z x y equals to minus ax minus by minus d by c is considered is here. Also the z x plus on comma y equals to minus a into x plus on minus by minus d by c is considered according to this here. Thus the z x plus y comma b x plus on comma y equals to z x y the minus a by c is here, given this value. Also the z x y equals to z x y minus 1 plus b by c is given here. And this is the buffer depth algorithm is 4 is considered, is plus easy to implement it, that means the plus hardware supported is here. And plus polygons can be processed in arbitrary order is given here, like your the plus first polygons, that like your the covered pixels is given. And you can see the cost memory is considered is here during to this year the movement of this. And also the color calculation sometimes done multiple times will be here, that means your the transparency is tricky. And another thing is here, that is the depth sorting algorithm, that is the one is here, that means your the depth sorting algorithm, image and object space is here. Aga painter algorithm is here, the sort surface for depth the drawing, depth draw the back to the font is you can see that this will be the draw this the back to this the font is here, just like your the draw is here. Object is considered, that means this will be the solid face. The one by one you can draw this, but you can see that this will be the one by one face will be created. But the depth sorting the algorithm 2 is the simplicity version sorting, the sort polygons for average or the frontal, that means the z value, that is the x y, and also this will be given to your the display. You can see the different that like your the arrow is considered, the different line is the movement up to here. This like the different display shapes, the 1 2 3 4 you have to here the red, and also the different line will be draw, like your the depth sorting algorithm is used. And similarly you have to consider it according to the zb 1 2 3 and 4, this like your the z displays here. And another thing is considered according to the depth sort algorithm 3, a polygon s can be drawn if all remaining polygons, that means the s dash, satisfy one of the following test states: no overlap of bounding rectangles of s and s dash, the s is completely behind plane, that is of s dash is here, and s dash is complete in front of plane of s, the projections s and s dash do not overlap is considered according to the depth sorting algorithm is considered. And another is here the depth sort algorithm 4, the no overlap of boundaries rectangles of s and s dash is considered. You can see this is the ZV is here, the S dash, that means your the S, this is the considered according to the display. And another things is here, that means the XB is find here. And another is here, the this is the first figure, and the second one is considered according to this the XB and the horizontal consist, and according to the vertical axis is the YV. You can see here, that means your the X dash is comes here the on a triangular the formation is here, that means your the s is considered according to your conical shapes will be considered according to your the depth sorting algorithm is considered is here. And the depth sorting algorithm 5, the 2 is here, s is completely behind plane of s dash, that means your the substitute of wall vertex of s in the plane equation s dash, and the test if the result is always negative, that means you consider according to your the during toward the horizontal axis, that means the x v is here, that means your the display is considered according to your the slanted line, that means color is given the orange color, and also the during toward the your green color also will be considered, that is a vertical axis the s dash, and also your the s is considered. And during to this horizontal and vertical component you have to fully visible that your the green color, that means the s dash and s will be considered according to this the negative approach will be found. And another thing is the depth sorting algorithm 6 is considered according to this, that is the 3 is here, that means the s dash is completely in front of plane of the s. You can see that is your the s dash, that is the always complement the S dash in plane is the equation of S, and test if the result is always the positive is find here. That means the ZB is here, that is your the vertical axis, and the horizontal component is considered, that means the XB. You can find during to this figure, that means your the is just, and the one is considered according to your the that like your 4 A's will be found, and another things will be considered to shifted to this your conical shapes is considered according to this, and there the result is always positive will be considered. And another things, the depth sorting algorithm 7, that means your the projections is and the is dash do not overlap is here. That means the few cases you can see, that is your projections will be considered, this will be not touching to this, and also this is the always the is dash in the plane equation to is dash is, and that test in the result is always the positive. And similarly the your 7 you cannot be seen here, that is the s and s dash do not overlap to each other. That means your the first phase you can see, that is the display, the s dash and the s will be here but not will be overlapping, that is the not in that. But second one you can see like your the solid phase, s dash and s not will be overlap properly. You can the depth sorting algorithm 8 is considered if all test phase the swap s and s dash, and restarts with this the s dash, that means the display is considers, that like your you can consider similarly to your this the first phases will becomes the v and zv, the display is the horizontal component, the x v, the s s dash and s double dash is find here. And depth sorting algorithm 9 is considers the problems circularly and the intersections, and also comes your the solutions cut up polygons is here. That means your the XIB and the YB, this is the different cut up polygons will be placed here. And also the second figure you can see that like your the different plane will be considerations according to this the here, that like the vertical and horizontal axis is considered. And also this will be cut this here. And the depth sorting algorithm 10 is considered is here. That like your that tricky to implement it, and the polygons have to be known from the starts. And also the slow, that means your the polygon square is here, and you can see that like your the find for certain type of object such as the plots of z equals to f x f function of x y, or the non-intersecting spheres, that like your the produce the exact boundaries polygons is comes here, that like you can see the during to this phase you have to find here, that means your the produce exact the boundaries will be considered, that like your the different the white colors will be given, and also the different color will be given here. The ray castings algorithm on is here, that means your the image space method and the related to depth buffer. Buffer order is different, that means you can see that like your the xb yb and zb you can consider according to your the one blue color is given during to this your the in front of this blue color, that like your the ray castings algorithm is here, and it concentrates that like your the normalized the view volume is considered according to that means your the view planes. And another things also will be seen, that means your the pixels, and your pixels is considered. And another things you can see that this font visible font equals to visibility also is here, that like your the you can say the different dotted points also will be considered exactly. And algorithm will be considered, that means the power pixels, and also the calculate intersections points determine the font on will be here, that is the you have to find that like your the recasting algorithm is concentration, that means your the different buffering will be here, that is the z axis according to this. Another is the recasting algorithm 2 is considered according to the for f buf, that is that array array is the nn, and of color is the frame buffer is here. And also the n is the integer, and this will be intersection, that like your the is here. And another thing is that z is the array is here, that is the max insect is here, that like your the third brackets close or real, that like the intersections. and another is be given here, that like your P array is counts, that is the max intersect of the object is the concept is here, that is dot object is considered according to this the for all, that is the 1 less than equals to I, that is the z less than equals to n2. Now for all pixel is considered here the for all object do is here, and another is the calculate the intersections and add this to z and p is here during to this, and keeping z and p sorted is here. That is the if n is greater than 1, then f b f is the in third bracket ij, that is the surface color, that is p suffix p is the function of on is the z function on is here, that is the value, and recasting algorithm 3 is defined the accelerations intersections calculation use the hierarchical boundary boxes is considered according to these figures. You can see that this that like your the different box will be given, and this is the different component of this will be draw by just like your the algorithm 3 is considered intersections calculation is a boundary box, and recasting algorithm is the 4 is find here, that like your plus relatively easy to implement. For this the some objects very suitable for intense instance the spheres and other quadric surfaces is considered. Another thing is here, the transparency can be dealt with the easily, and minus object must be known as in advance is here, during so solo, that means your the object has objects, that is the pixels, and comma is the little the coherences comes here, little coherences comes here, that like is that the plus the special case or the case of ray tracing is find here, that means your the comparison is comes, that like the hardware available, hardware is available, use this depth, uses depth buffer, that means you're the possibly in combinations with backface eliminations or depth sort for the part of skins is here. If not shows not shows the dependence on complexity skins, and type of object is find here, that means you're the simple screens is here, few objects is considered according to this the depth sort, and quadric surface under the ray castings, and the other is the depth buffer is come here. The many additional method to boost the performance can trace the scales sense and the decompositions etc is find here, that like your the open gl backface removals is here, that means the gl enable, that means here the gl cull underscore face is here, that is the calling on, that means the gl cull face, that means your the modes the comma, and specify what to call the mode is will be given, that means your the ccw font is given here, and like the one arrow is given to your the down direction, the point is here, that means the 1 2 3 4, and similarly this will be again cw back is the here, that means the one is the font. Now this is the back, that means 1 2 3 4 will be considered the orientation matrix. Orientations matrix comes if you want to change the default the gl font face, that means the vertex over order, that means the order of vertex is here, vertex order equals to gl underscore cw, or the clockwise will be rotates, that means your the gl underscore ccw comma is the counterclockwise, that means your the default rotate is rotation is found. The open gl depth buffer functions, the gl enables, that means the gl depth underscore test, and also the turn testings on the gl clear, that means the gl depth underscore the buffer underscore beat, and the clear depth buffer is count here, the that is the typically once per frame, the gl depth the condition is count here, that means the change test use the conditions the gl the less and the closer visible default, that means the gl creature, and also the further visibility is find here, that means the not range between the z near and the z far is mapped to 0 1 using 1 or 2 byte precisions, that is the if z far has an unnecessarily high values, the you lose precisions and the artifacts can appear. The thank you students.